Before we begin, we would like to acknowledge the traditional custodians of the land in which we are based, the Gadigal people of the Eora Nation, and extend that respect to the elders past and present.
Hi everyone, welcome to EWB UNSW's second Inspire podcast of 2021. So a quick introduction as your host today, my name is Aidan. I'm one of the project coordinators for EWB UNSW and a second year student studying commerce and computer science. Joining me today is Dr. Beena Ahmed, who is the co-founder of Say66 and also one of UNSW's electrical engineering lecturers. Thank you for joining us, Beena. Could you introduce us?
Hello, everyone. As Aidan said, I'm a senior lecturer in electrical engineering and telecommunications. I teach undergraduate courses in digital design and electrical engineering design. My area of research is signal processing. So specifically, I work with speech signal processing and biomedical signal processing. And out of my research, as Aidan mentioned, I've got a startup called Say66.
Could you let us know your long-term vision on children's speech recognition and speech therapy?
Currently, speech recognition tools are developed mostly for adults because they are the primary users of speech recognition technology. So when children or people with speech disorders try and use them, it's a bit of a hit and miss. Sometimes they work well, sometimes they don't. And the reason being their speech sounds different to adults, typical adults. And so, which is rather unfair, right? Because then we're excluding a whole segment of society from such a beneficial tool. I mean, we're so dependent on speech recognition to do small, mundane tasks, and where these are people who could actually benefit a lot. So somebody, say, with a physical impairment of some sort could really benefit from having a speech recognition tool, and that helps them control devices in their room. Similarly, children could benefit from reading tutors or speech therapy tutors. So my whole rationale behind my research is to actually try and help communities who are traditionally excluded from speech recognition.
Awesome. Yeah, so what drove you to develop these tools and technologies to help children's speech disorders? What brought about this kind of whole vision?
It came rather accidentally. I had a friend who was a speech pathologist, and she was explaining the difficulties she faced in engaging children in speech therapy long-term, and how because of the shortage of speech pathologists around the world, they had an excessive workload and they couldn't devote as much time to help these children, and also it's costly. And so families also struggle to pay for the cost of speech therapy. And so that got me thinking. At that point, I've been working on speech, PhDs in speech, but I hadn't actually looked at disordered speech. But that got me thinking that the research I've been doing, the techniques I've used could actually be applied here and would actually serve a community that was in need.
It's exciting to learn that you're trying to improve speech recognition for these younger tech users through your AusKid Talk projects. So could you let us know more about this project's goals and progress?
Okay, well, speech recognition uses machine learning models. So these are models which are trained using large data sets. So every time we use, for example, Siri or Google or Alexa, we actually are contributing our speech to those companies, and they use our speech to improve their models. Now, because children are not big users of these technologies, that's why the models are not good for children. And traditionally, parents are reluctant sharing their children's speech, and it's also difficult to collect children's speech. So if we are to develop accurate models for children that can be used in speech recognition, we need to have a data set of children's speech. And the whole rationale behind AusKid Talk is to collect a large enough data set for children's speech so that we can develop improved speech recognition tools for children. So it's still not going to be as large as a data set that is used to develop Siri or Google, but what we can do is that we can then adapt those adult-based models so that they work better with younger people. And so So we're currently collecting, as part of the project, we're planning to collect speech from around 600 to 700 children. And so we've crossed the halfway mark. We're still looking for volunteers. So if any of your listeners have younger siblings or cousins who they feel would like to participate, please go to our website and sign up, or get their parents to sign up and bring them in. Yeah, because we really need young participants.
So you mentioned that a lot of data is required to train these machine learning models. How much data is actually required per child in order to actually be useful to the model?
Per child, you don't need that much data. You need like 15, 20 minutes. It's more about the amount of people you have the data from. So typically you'll have like thousands of hours of speech that is used, and that thousands of hours of speech is collected from tens of thousands of people. Because speech is such a variable thing, like you sound different from me, I sound different from the person in the next office. There's such a huge amount of variability, and you want your model to capture all that variability. So if you don't have samples from a large proportion of people, then your model is going to be biased to certain areas. So if we think back to, I don't know if any of your listeners are familiar with this, but when Siri first came out, it was very tuned towards American speech because that was the model that they were using. They trained it, that was the data that they had acquired. It was only as more and more users started using it in Australia that they got Australian speech, then they did some accent adaptation, and now it's a lot better.
And so your whole goal is to build a children's data set in order to help speech recognition in their
Yes,
demographic.
Not just speech recognition, but general speech based applications. So speech recognition is one of the biggest one, but then you can analyze children's speech. So the team includes not just engineers, but the OzKid Talk project includes linguists, we have psychologists, we have speech pathologists, and they're all interested in how children develop their speech, how they use speech in different circumstances, how disordered speech differs from typical speech. So, I mean, once we have a data set, then you open up avenues for researchers in a lot of different areas.
You've opened my eyes up to that. On the topic of speech therapy, I understand you've developed a video game, Say Bananas, with your company Say66 as a children's speech therapy tool. Can you let us know what the benefits or differences are with a software approach to speech therapy compared to more traditional non-remote speech therapy practices?
Okay, so Say Bananas is supposed to support traditional speech therapy. So the way traditional therapy works is a child will go in for a session once a week or once a fortnight. And then when they go back home, they practice their exercises that the speech pathologist has prescribed to them. Now, the issue there is that a lot of these exercises are, obviously it's repetition, right? So they'll be asked to say certain words, certain sentences multiple times. It's not very engaging. And children, as you know, in the best of times, are hard to keep motivated to do even homework, let alone speech therapy. And so the idea is to make it more engaging, to have a game which has speech therapy embedded in it. So that will make it more engaging. Then the other side of it is that a child needs to know how well they are doing, right? So if you say a word, say bananas, the child needs to know that they have said it correctly. The issue is that parents or guardians, they know how, they can understand their children. They are tuned to it. And so even if a child makes a mistake, they'll understand it. So they're not very good at giving feedback to children because they won't be able to correct their mistakes. So that's a big problem, is that when children do their practice, they don't know whether they've said it right. So they might practice something wrong for 2 weeks, and then when they go back to the speech pathologist, they're in the same place. They haven't improved. So in Say Bananas, we've got this combination. We've got like a platformer style game, sort of similar to those Mario style games, which is engaging. engaging. And then we've using speech recognition to actually recognize what the child is saying and give them feedback. So if they said ball instead of tall, we'll tell them you made a mistake, try again, that sort of stuff. And so that way the child is getting timely feedback and can correct their mistakes.
All right. Yeah, it sounds like a great approach towards, adding on to this traditional speech therapy and helping, keep kids engaged with speech therapy. So I understand that you're also looking into utilizing acoustic and phonetic information in speech to help identify the risk of dementia and speech sound disorders. Have you made any progress in this idea, and could you tell us more about it?
Yes, we've actually made quite a lot of progress. So I'm working with some neurologists and doctors up in UNSW medicine. And so they are currently doing a large intervention study where they are collecting recordings of people above 55 doing a memory test. So basically they repeat a certain sequence of words. And if you are struggling with memory issues, then when you are asked to repeat a random sequence of words, it becomes more challenging. So even if you don't have dementia, you actually can have there are early markers of what's called pre-dementia in speech. So the way it happens is that you're going to think more about what those words are. So you're going to have pauses between those individual words. You're also going to take more time saying each of those individual words, and then how you say each of those words changes. And so that's where, as you mentioned, the acoustics of those word production changes. So what we've been able to do is we've been able to predict with accuracies of up to between 80 to 90% whether a person has pre-dementia. And that's huge because currently, if you have dementia, you can't go back, right? There's no treatment for dementia. The only thing you can do is if you have pre-dementia, you can do treatments to delay the onset of dementia. And that makes a huge difference to these people, their quality of lives, So, and that's what the study is about, actually, the one that we're collecting the data, where once we identify people with pre-dementia, they give them interventions to delay the onset of dementia.
And so how do you guys identify the risk of dementia? Is it through like a machine learning algorithm the same way, using acoustic and phonetic information as data?
Yes, exactly. So, so we've got those recordings of those 15 odd words that people have said. And so we're extracting acoustic and phonetic information, feeding it to a machine learning classifier, and basically going risk or no risk of dementia.
Mm-hmm. That's a really helpful tool. From what I know, one of your future goals is to develop a machine learning algorithm to recognize emotion in children's speech. However, there are some cases where our speech doesn't necessarily reflect the emotions we are feeling. So for example, I might be feeling down, but I might not show it in my speech. So in these cases, would a machine learning algorithm still be able to detect a correlation between speech and emotion?
Yes, it definitely gets harder if you're trying to conceal your emotion. And those are cases where these algorithms are less reliable. However, even if you do try and conceal your emotions, sometimes they're very telling, subtle signs of emotion that we can't actually listen. So it goes to the acoustics of the way we say our word. So we're going to be less, right word would be, if I'm trying to think of a layman term, less natural. And so that's what these acoustics are trying to pick up. I mean, the application is not generally in places where we're envisaging using. The biggest application is, say, mental health helplines, for example, where you're trying to pick up somebody who's distressed and needs, you're trying to triage them into this person needs immediate help versus this person can be helped in a little while longer. So that's where these algorithms like these are really, would be really beneficial.
Right. And so is this mainly targeted towards children? Because your main focus is children's speech therapy and recognition?
There's a lot of work already done in adults on this, and some of my colleagues here, Julian Epps, Vidya Setu in electrical engineering, have actually been working on that for a long time. With adult speech. Children's speech, the issue with children's speech is there's not much data out there. And so we haven't done much work on it. The goal is, in OzKid Talk, we're actually collecting children's speech in which we have elicited some emotion. And so that's something we'll be working on in the future, to try and use that speech to try and identify emotion in children.
Okay. So given your background in electrical engineering, what inspired you to move into developing machine learning algorithms, pattern classification, and working with deep neural networks?
So when I started, after I graduated, I worked in automation. And initially I was working very different signals. These are signals from sensors used on factories, industries, SCADA systems. And so I always liked the idea of trying to decipher or decode patterns or information from data. And so that's how I ended in signal processing. And speech somehow, speech was interesting in the sense that we use speech every day in lots of different ways, you know, and there's so much richness in speech that when I started working in it, it was still, even though people have been working on speech for decades, it's still an unknown territory. And so it fascinated me, the fact that you could express so much with just a few words, not just what you're saying, but as you talked about emotion, it's a very rich form of communication. And so the idea of decoding patterns in speech fascinated me, and that's where I ended. And then as time progressed, you come up with different intersections of where to go, you know, and you sort of look for things that interest you more. So for example, the dementia one, it's fascinating, you know, to think that you could have a tool one day, maybe on an app, with patients that are at more risk, right?
Yeah, it's really cool to see how you've moved in from like engineering and then towards machine learning and then intersecting that with healthcare.
Yeah, it's something that often people don't think about as electrical engineers doing. You know, we have this people tend to stereotype electrical engineers as mostly power or communication, whereas some of the tools and techniques we use have wide-ranging applications, you know.
Yeah, I had the same closed-minded thinking towards electrical engineering. I mainly thought it was like circuits, and that was basically it. But you showed me the light today. So moving on, like, what's the most rewarding part about what you're doing right now?
I guess there are two aspects of it. There's a teaching part. When I interact with students, when I explain things to them and they actually, you know, it dawns on them, they understand it. It's like a light bulb flickers in their minds and you can see that change in their face. That's really exciting and it's really rewarding. And the other thing is when my research actually, it's translated into products. So for example, right now I'm really excited about Say Bananas because this is research I've been doing for 10, 11 years. Now we're actually at the point where we have a product that people can use. We've actually helped do something to help people.
Yeah, that sounds really rewarding. I'm interested in seeing how Say Bananas moves forward. I've also read that one of your interests is looking at the correlation between physiological changes and mental stress to develop these biofeedback mobile games that teach users relaxation skills. What are the benefits of this kind of application for the general public?
On a bigger picture, it's the same thing, you know, with Say Bananas, where I talked about when a child does speech therapy, they don't get feedback. So in Say Bananas, the goal is there. So it's the same thing when you're trying to relax. I mean, we all suffer from stress. Everybody does different things for relaxation. And sometimes we try new things, but we don't know whether it's working, you know? You sort of self-evaluate yourself, but you don't know whether you're doing it correctly. You might know whether you've relaxed or not, but you don't know whether you've done the exercise correctly or not.
Right.
And so that's the whole concept of biofeedback and relaxation and stress, is that we're collecting all these biosignals, so heart rate, skin conductance, and you're trying to figure out whether whatever you're trying to do to relax is actually helping you.
So my last question is, do you have any advice for any students or passionate individuals that want to pursue a similar path to what you've taken?
Advice is hard. I don't have a well set out path that you can take. What I would advise is don't be shy and explore the opportunities that are available. If you find something that sounds cool or sounds interesting, go talk to the lecturers who are working in those areas. Try and learn about it. Go online, look up blogs or websites that talk about it. And you never know, if you feel that connection with that idea, you get passionate about it, then you should give it a try. I mean, what have you guys got to lose by trying something? You're young, you don't have any liabilities, so give it a try. You never know where it could end up, where it could take you.
Are there any kind of like projects that university students can participate in that could maybe like help progress their career? Or is it mainly that they should just be trying to develop their breadth of knowledge in order to help later on?
Well, the university has some programs such as the Taste Research program. With Dr. Vidya Setu and myself, we have a sort of a lab, a signal processing machine learning lab. And so we're actually just going to be announcing, asking for students who want to be involved in research projects in our area in machine learning. So definitely there are opportunities if students want to improve or learn about these things. So there are opportunities out there for students to do that. They should take advantage of those. Okay,
yeah. Sounds like a great opportunity. That concludes today's podcast. Thank you very much for joining us today. It's been a pleasure talking to you, Beena. As I said again, you've opened my eyes to the world of speech recognition and therapy. I hope for the best in all your projects, and we hope that our viewers also enjoyed today's episode too. Do you have any final words?
No, I'd just like to thank you for having me. It was fun chatting to you, and I'm glad you found the talk interesting, and I hope other people do. And just reach out to me if you have any questions, not you, but all your listeners as well too.